This is 14.6, Solving Rational Equations for Math 102. So we're going to start with a basic equation, which is what we call a ratio. And so a ratio is simply a comparison of two numbers. We usually write ratios as a fraction, A over B. That's the rational expression. You can also write them as A compared to B, or you can sometimes see them as A colon B. But we're going to be focusing on this written expression. And so when we have what we call two equal ratios, that's what a proportion is. Two ratios that are equal. So we're going to set A over B is equal to C over D. And to solve, we are going to use cross multiplication. It's multiplication. So if A over B is equal to C over D, then we can say that A times D is going to equal B times C. And that's how we're going to solve it. So the first ones that we're going to look at, we're going to say, first you have to state any restrictions on the variables. And remember, restrictions are things that are going to make those denominators zero. So I come over here and I just kind of make a little, column or whatever. Restrictions, I set each one of these denominators cannot equal zero. So for both of them, it says that x cannot be 0. So of course, when we enter it, we are only going to enter the 0, 1. So it's going to say restrictions, x cannot equal, and then you're simply going to stick in 1, 0, okay? Because that's going to be important. When we solve rational equations, now we're going to have to look at restrictions because sometimes we're going to get a solution that truly is not a real solution. So now what we're going to do is we're going to cross multiply. And I think that the easiest thing to do is to actually write it out. So depending on which diagonal you start, I'm going to take 4x and multiply it by the entire thing, x minus 7. And then I'm going to take that equal and take 8 times 2x. I think sometimes when you first start out, that's probably the best way to go about it, is go ahead and write it before you actually try to multiply. Now we're going to distribute. That's going to become 4x squared minus 28x, and that's going to equal 16x. Since I have a quadratic, I know that the way to solve quadratics is set it equal to 0. And so I'm going to have to subtract the 16x. And so now I get 4x squared equals negative 44x equals 0. And in order to solve for x, because that's what my goal is, to solve for x, I have to take I have to factor this because there's a quadratic. So I'm going to pull out a 4x, and that leaves me with x minus 11 equal to 0. Then I set each of those factors equal to 0, and I get x is 0 and x is positive 11. And here's where you got to stop and check. 0 was a restriction. Okay, see right here, it says that x cannot equal 0. So I have to throw out that solution. So my solution is only going to be the number 11. Okay, and if you don't throw that solution out, then you will get partial credit. It will be partially wrong because you didn't stop and check that answer. Okay. So going to the next one, we have our restrictions. I'm just going to do this, restrictions. X cannot equal 0. That's the first denominator. And x minus 8 cannot equal 0, which says that x cannot be 8. Then I solve it. So 4 times x is 4x, and that equals 8 times x minus 8. Now, if you can avoid that step of writing it down and just go right to 4x equals 8x minus 64, that's perfectly fine, okay? I distributed as I went, and I didn't have to write that intermediate step. Now, don't lose your mind here. This is just a linear equation. So we don't have to factor anything. We don't have to solve, all we have to do is solve it like we would a regular equation by moving over. I'm just going to subtract 8x. And so that gives me negative 4x is equal to negative 64. And then I'm going to divide by negative 4. And so x comes out to be equal, that's positive, and 64, I think it's 16. 64 divided by 4 is 16. And 16 was not a restriction, so this is a true solution, okay? Now, they get a little bit more complicated. We just have to make sure that we're watching our steps. We only set for the restrictions, we only set denominators with variables not equal to 0. We don't care about the numerators, it's just the denominators. So our only restriction in this one is that x cannot be 6, okay? So now we can go ahead and cross multiply. So if you need to, write it out like this, and then take 11 and multiply by x minus 6. So as I distribute, I'm going to have 20x plus 8 is equal to 11x minus 66. Again, just a linear equation, guys. So we solve it by subtracting 11x. So that gives me 9x plus 8 is equal to negative 66. And then I'm going to subtract 8. And I get 9x is equal to negative 74. And then I divide by 9, and x is negative 74/9. And that's okay. As long as we didn't get 6 as our solution, that's going to be an okay answer. And I can't reduce it anymore, so I would just leave it like that, okay? All right, so the next one, we're going to do the same thing. Let's find our restrictions first. So x minus 3 cannot equal 0, so x cannot be 3. 2x minus 3 cannot equal 0, which says 2x cannot equal 3, which says x cannot be 3/2. So those are my two restrictions, positive 3 and 3/2. Now I'm going to cross multiply. So I'm going to take 12 times x minus 3, and it doesn't matter which diagonal you start with, and that's going to be equal to 8 times 2x minus 3. So I get 12x minus 36 is equal to 16x minus 24. And I am going to subtract 12x from both sides. So that gives me negative 36 is equal to 4x minus 24. I'm going to add 24 to both sides. And that gives me 4x is equal to negative 12. And then I divide by 4. And so x is equal to negative 3. And negative 3 is okay. If I had gotten positive 3, that would have not been okay. But negative 3 is a solution, and so that would be my answer. Now, the application problems of proportions are by far the easiest, as long as you remember to write the two things that you're comparing out in words first, okay? So what I would do is on this application problem, first of all, I would probably change this to a decimal, 3 3/4. I can write it like that, okay? So I am comparing inches to miles. And when I write this out, I always start by writing blank equals blank. That first proportion should always be given to you in the information. So if you look at it, it says 1 inch represents 60 miles. So there's my first ratio, okay? Now it says, what length does a measure of 3 3/4 inches? Inches is on top, so I'm going to put that on top. And I want to know how many miles. Now, once you set up your proportion, then it's just a calculator game. So this is how I do it. I find the two numbers that are diagonal from each other, and I multiply. And then I divide always by the number diagonal from the x. And in this case, it's just 1. So 60 times 3.75 is 225 miles. Okay, and it's a good idea to always get in the habit of labeling your answer. All right, so the next one we are comparing to defective, or I'm going to just put defective, to samples. Okay, and I'm just kind of picking out some words. Defective comes first, sample comes second. Okay, so I start blank equals blank. I'm going to fill in that first ratio, 3 defective computers in a sample of 20. They want to know if this is consistent, how many defective, that goes on top, if we have a batch of 2,400. So we cross multiply, 3 times 2,400 divided by 20. And when I do that on my calculator, I am going to get, 360. Let's just make sure that's right. 2,400 divided by 20 is, yes, 360. And so that would be 360 defective computers in that batch. Okay. All right. The next one, we've got a professor to students. So I'm going to say professor to students. I'm going to go blank equals blank. It tells me that there is 1 professor for 23 students. If we have 1,600 professors, we want to know how many students. So again, I am going to multiply 23 times 1,600 and divide by 1, which I don't really have to do. And I'm going to get 36,800 students. Okay? All right. Now the next one, we're comparing cups of chocolate chips to dozens of cookies. So cups to dozens. And I just always pick the first thing that I see, the first number that I see, that's the first word that I see. And that's how I fill in my ratios to get my proportion. So it says it takes 2 cups to make 5 dozen cookies. We want to bake 17 dozen cookies, and we need to know how many cups of chocolate chips. So 2 times 17 divided by 5. And you can leave this as a decimal if necessary. And it does come out to be 6.8 cups. That's a lot of chocolate chips, okay? So I'm going to stop there, and then we'll pick up on the next solving rational equations.